Hi everybody, welcome to your first video in section 2 of unit 3 for geometry. So this section is on symmetry, right? So symmetry of shapes as well as compositions of transformation. So that's what we're going to be talking about in this section. As always, you can see the slides that I would normally put up for you on the left side of your screen, and then the notes here on the right side of your screen. And as always, I am doing my annotation with Cami so that it's a little easier for me to write on the screen for you all. All right, so let's go ahead and jump into it, okay? So symmetry is something that you have seen before. Like you've seen it in basically really since elementary school. But the kind of symmetry that you have seen most often is something called reflectional symmetry. Okay. Right? Reflectional symmetry, which is what you're used to. That's when you take a shape and you cut it down the middle, or you try to figure out where the fold lines are. Like, how could you take it and fold it perfectly in half? So that is reflectional symmetry, because basically what you're doing is you're putting a line of reflection straight through the middle of the shape. Okay? But that is not the only type of symmetry. There's also this thing called rotational symmetry, which I'm going to talk about in this video here. Okay, but let's talk about reflectional symmetry, just kind of give you a review, because these are some things that you have seen, hopefully that you've seen before. So a line of symmetry, which is kind of how we deal with reflectional symmetry, is an actual line. So it could be an actual line in the, like physically on the figure, or an imaginary line. And typically we draw the imaginary lines with little dashes, like you can see in the kite right here. Okay, so it's an actual or imaginary line that creates a mirror image on either side of the line. Okay, i.e., it divides the shape. If I could type, that would be great. The shape in half, or in two equal, actually, I really should say congruent parts. Okay. So what's neat about lines of symmetry is that oftentimes in shapes you can definitely have more than one. That happens a lot, right? Shapes can have no lines of symmetry, 1, 2, 3, 4. They can have an infinite number of lines of symmetry also. So a figure can have anywhere from 0 to an infinite number of lines of symmetry. Okay, essentially what you're looking for here is a perfect fold. Okay, that's basically what you're looking for. Okay, and then there's a couple of rules that we have for reflectional and rotational symmetry, which you can't see on this slide, but I think I put on the next slide here. Let's just check. No, I didn't. Looks like I did not do that. Whoops. So what I'm going to do, y'all, is I'm going to pull this over a little bit so you can see a little bit more clearly what I'm writing on the right side of my screen. Ooh, let's zoom out a little bit. Okay, so there's a couple of reflectional symmetry rules that we deal with, okay, or things that are kind of common to all lines of symmetry. So lines of symmetry will bisect sides and angles, right? So you can take, say we have like a heart, for example, that we're drawing. Not a perfect heart, because, you know, I'm drawing it by hand, but we do the best we can, right? So if I put a line in here straight down the middle, whoop, okay, so what this has done is it has bisected. I really did not draw this very well, but you can kind of see what I mean, even with my bad drawing. So what you can see, hopefully, is that down here, right? This angle down here is cut in half. It's bisected, right? You can also do this with more common shapes. So say like we have a triangle right here, okay? And then if I draw a line straight down the middle, not only is this angle up here bisected, this side down here at the bottom is also bisected, right? So we divide it into those two congruent parts right there, okay? Right, and then the other reflectional symmetry rule is that circles have an infinite number of lines of symmetry. Okay, you can draw a line anywhere through the middle of a circle and it will cut it in half, right? It's because of the nature of circles and how they are. All right. Okay, so give me just a sec. I have to pause and reset to get this back to where it was. And the size is a little bit different. And then I'm going to talk to you about rotational symmetry. Okay, so we talked about reflectional symmetry. Let's talk about rotational symmetry, which is a little bit different and something that you may not have heard of before. Okay, so rotational symmetry is a type of symmetry more that deals with obviously with rotations, right? You can almost think of like if you all ever had those pinwheels when you were a kid, right? That were on a stick and they had like multiple, it almost looked like a fan that you would blow and it would spin, right? That's essentially what you're doing when you're trying to figure out the rotational symmetry of a figure. Okay, so a figure has rotational symmetry if you can rotate the figure less than 360 degrees, okay, i.e. less than one full turn, okay, and the figure maps onto itself, okay, and here is what I mean by that, okay, and I'm going to zoom in a little bit on this side so that I can draw something for you. Okay, so I am going to draw just a rectangle. Okay, and then what I'm going to do is put a dot inside of it. Okay, so essentially what I'm doing here is I'm putting pretending that I have this shape, right? Pretending that I have this rectangle shape and I'm putting like my finger or a pen or a pencil directly on that dot in the middle. And what I'm going to do is rotate the shape around itself. So it kind of turns around that middle point. Okay. And then I have this blue dot here in the corner that I'm going to track. Okay. So I should be able to rotate this. Ooh, maybe it won't like me rotating it. I think it won't let me rotate it. It may just let me change its size. So what I have here, right, with this rectangle, all right, if I take this and I rotate it, oops, not what I wanted. So what I can do is essentially when I take this and I rotate it, what I'm doing is this rectangle is like turning and rotating around that middle point. So if I take it and I turn it and I rotate it 90 degrees, actually, hold on one second, y'all. I need to pause this real quick and redo this rectangle because I'm going to run out of space and run into some stuff. So give me just a minute. Okay, there we go. I changed the size of my rectangle so that it wouldn't completely block these other lines here. Okay, so if I take this and I rotate it around this black dot right here in the middle, okay, it's going to look something like this. So I'm taking it and I rotated it 90 degrees. Okay, 90 degrees counterclockwise, right? So now this blue dot that I had up here if I watch it and I follow it, is now down here. Okay, so this shape right now is not mapped onto itself, meaning that I can see the original shape underneath the new shape, the rotated shape. Okay, but if I take it and I rotate it again, okay, so if I take it and I rotate it one more time, and I'm going to change the color of this one so that it's different. Okay, if I take it and I rotate it one more time, now it's mapped on top of itself, but that blue dot is not up in this corner. It's moved now to this corner. Okay, so this shape has rotational symmetry because I can turn it on top of itself less than one full turn. So less than 360 degrees, less than one full circle to get this blue dot back where it was, okay, where it was originally. Right? I can turn it less than one full turn and the figure maps onto itself. Okay, so that's what rotational symmetry is. And you can kind of see it here on the left-hand side of your screen in this picture right here. Okay, where this is the point that they tracked up at the top, and then they took it and they rotated it. So now this point A is down here in the bottom right corner, but the shape looks exactly the same. It's just been turned around a point in the middle. Okay, so let me zoom out a little bit here. Okay. Right? There are some shapes that have that can be turned many times and map onto itself. But there are other shapes that don't turn at all, like they don't have rotational symmetry because you can't rotate them and have them map onto it themselves. Okay, so when we're talking about rotational symmetry, oops, sorry, y'all, is my cell phone. When we're talking about rotational symmetry, there are two things that figures that have rotational symmetry have that are related to that rotational symmetry. So the first is called the order of rotation, which is the number of positions in which the rotated object is unchanged. Okay, meaning that's how many times can I rotate the shape around itself? How many positions does it map onto itself in one full turn? Okay, then the angle of symmetry is the smallest angle that maps a rotated shape onto itself. Okay, so going back to this rectangle example, right? If I do one turn of 90 degrees, right, that gets me this pink rectangle and it's not mapped back onto itself. But if I do one turn of 180 degrees, it maps back onto itself. And then if I did another 180 degree turn, this blue dot right here in the green guy, the green rectangle would end up back where it started. So we've done one full turn, one full 360 degree turn, and the shape mapped onto itself twice. Okay, so the order for a rectangle would be 2 because it's mapped onto itself twice in one full turn. Okay, and then the angle is how many degrees we rotate it each time. And we rotated it 180 degrees each time for the shape to map onto itself. Okay. So there are a couple of rules, and really there's only one major rule, and then there's this kind of other cool like rule that shows up every so often, which is just kind of neat. Okay, but really, if you're going to remember anything about rotational symmetry and calculating stuff with rotational symmetry, it's this formula right here. Okay, so if I want to know the angle of rotation, right, the angle of symmetry, I have to take 360, which is one full turn, and divide it by the order of rotation, or how many turns I'm doing, in order to get the angle of rotation. Right? To take the full number of degrees, divide by how many turns you have to rotate it, and that will give you how many degrees you have to rotate each time. Okay, and then there's one other, like I said, one other rule that's just kind of neat. which is in regular polygons. So that's like squares or equilateral triangles or pentagons, octagons, hexagons, right? Things like that. Regular polygons, which are figures where all the sides of that figure are the same length. The number of lines of symmetry, which is the reflectional symmetry up here, is equal to, okay, it equals the order of rotational symmetry, okay? And that's also equal to, it equals both the order of rotational symmetry and the number of sides, okay, which is kind of cool. And you'll see down here in an example in a second, okay? So here. All right, so give me just a second because I need to reset my screen a little bit here. But we're going to talk about these lines of symmetry here in these four different shapes, lines of symmetry, as well as order and angle of rotational symmetry. So give me one sec to kind of rework my screen. I'll be right back. All right, folks, so I zoomed in on your actual notes page so that you can see what you would actually be writing and doing on your side here. Okay, so what we're going to do here is we're going to draw the lines of symmetry for reflectional symmetry, okay, and then we're going to figure out the order and angle of rotation for each of these figures here, okay? So let's do this bright pink guy. Okay, so for the first one here, this technically overall is a circle, right? So really it should have an infinite number of lines of symmetry, but we have these extra things in the way, right? So there's the eyes and the smile. So there's really only one line that you can draw. Whoops, didn't want that. That's a square. I want a line, not a square. Okay, so you can really only draw a line straight down the middle to make that perfect fold line right there, okay? And then if we're thinking about rotational symmetry, okay, there's really no way for me to rotate this so that it looks exactly the way that it looks right now because of these eyes and this smile, right? If I rotate it like 90 degrees, for example, whoop, hold on, let's change the color. If I rotated it 90 degrees, for example, it would look like this, right? If I rotated it 180 degrees, it would look like this, right? And so on and so forth. So this one actually does not have an order of rotational symmetry. So you would just say none here. Okay. Right. So that means that there's no like angle. Technically the angle is 360 degrees, but like that doesn't actually mean anything, right? Because it puts you right back where you started, okay? So let's look at B, because this one's going to be a little bit different, okay? So this is a star, and we can definitely draw lots of lines of symmetry for this one. So we can draw one straight down the middle like this, but we can do that at each vertex. So we can draw a line through at this point, a line through at this point, and then finally this point right here, okay? So I have 5 lines of symmetry here, okay? Then if we're thinking about order of rotational symmetry, right? So let's say we have our dot in the middle that we would rotate around, and then we have a dot that we would keep track of, right? So I can take this and rotate this shape about this far, and then this blue dot now ends up here, right? And then I can do it again, and then that blue dot will end up here once more, and I'm kind of trying to alternate so you can see rotate, and it ends up here. Okay, once more. It ends up here until finally it ends up back where it started. Okay, so my order of rotational symmetry here is how many times did this blue dot map back onto itself until it got to back where it started, right? So I count, typically when you're doing this, you don't want to count where it starts, okay? So you would count, there's 1, 2, 3, 4, and then 5, you have to count when it comes back to where it was originally. Okay, so my order, where that dot was originally, so my order of rotational symmetry here is 5. Okay, and then my angle is 360 divided by 5, okay, which is 72 degrees. Okay, let's look at part C here. Okay. So if we are drawing our lines of symmetry, we can definitely draw one straight down the middle like this, right? A straight vertical line. We can also draw a horizontal line through the middle. But then we also can draw on these diagonals right here. Okay, which I didn't quite put that in the right spot. Let's move that a little bit. Okay, and then same thing for this diagonal. Okay, so 4 lines of symmetry, which kind of makes sense because you have this this square right here, right? That's kind of our limiting factor in how many lines of symmetry we have. Okay, so then let's now think about the order of symmetry. Okay, so again, you have your point in the middle that you're rotating around, which you can see here, it's kind of in pink because of where all my lines intersected. So let's say I'm going to track this corner point right here. Well, I can take this and rotate it along this line until that point ends up down here. I can do that again twice to get the blue point here, a third time to get the point here, and then a fourth time to get it back where it started. So the order of rotational symmetry here is 4, okay, and the angle is 360 divided by 4, 360 degrees divided by 4, which is 90 degrees, which kind of makes sense when you think about a square, right? Every time you turn it 90 degrees, it ends up looking right back like a square, okay? All right, so it's going to take me a second to draw the ones for part D. So pause the video, see if you can figure out the where the lines of symmetry are, as well as the order and angle of rotational symmetry, and then check back with me to see if you got the answer correct. All right, folks, so here is the last one. Like I said, took me a little while to draw here, okay? But I have my 4 lines of symmetry that I have drawn in, okay? But what I'm kind of seeing now is that I actually have some lines of symmetry that I missed, okay? Which I kind of intentionally didn't draw so that you could see this, right? So typically when we think about lines of symmetry, we think about these large points, right? Or these very like obvious lines of symmetry, but notice that you can also draw smaller lines of symmetry and divide this like snowflake in half this way, for example, and this way, right? So kind of through these smaller crevices here, this way and this way, okay? So this kind of snowflake looking thing with all these lines of symmetry and the dots in there, it actually looks kind of cool. But this one actually has 8 lines of symmetry, okay? Now the order of rotational symmetry and the number of lines of symmetry won't always match, right? So like that's kind of what happened with our smiley face right here. It had 1 line of symmetry, but it didn't have any order of rotational symmetry. They aren't always going to match, but one thing you probably noticed about these other 3 shapes, the star, the square inside the circle, and this kind of cool flower snowflake looking thing, is that they all looked like regular polygons, right? Where you have all of these sides and things that look like they're about the same length. Okay, so my number of lines of symmetry is 8. Okay, my order of rotational symmetry is 8. You can kind of see the blue dot that I tracked going all the way around. Okay, so there were 8 spots there, and then the angle is 360 divided by 8, which is 45. All right, y'all. So that is it for this notes video on symmetry. I will see you in the next one where we're going to do some more practice problems like these. So I'll see you in the next video. Bye, everybody.